Welcome to Brain Vision.
Okay, so this question, we have a plastic circular loop with radius r. So this is the loop that I have drawn. Just going to define the central axis, and it has radius r. And it has charge q. And then I'm going to make it spin like that in a counterclockwise manner. And then there's a magnetic field parallel to the plane of the loop. So I'm going to make the B pointing to the right. That's the magnetic field. And then we are asked to find So this is the formula that we are going to use because in the context of magnetic field, and then when we are interested in the torque acting on a loop, this is the formula that we have. This is the torque equals to the magnetic moment mu cross B. Okay, so in this case, in this problem, B is kind of known. It's pointing to the right with uniform value B. So the task that we need to do is to find magnetic moment mu. Okay, and if you read the chapter, the definition of mu in this case for a circular loop is the current times the area vector. Okay, and then the current is just the charge divided by time, the time it takes to make one round, and then the area vector is just the area of the loop, which is pi r squared, and then the direction is in the y direction. Okay, I need to define my coordinate system. So this is x pointing to the right, y will be pointing up. Okay, and then the area vector for the magnetic moment, you use the right hand rule. You curl your right hand around the direction of the rotation, and then the thumb will tell you the direction of the area vector. In this case, if you do it, then your thumb will be pointing up, which is in the positive y direction. Okay, then the next thing is the 1 over t. So we recall, so omega is 2 pi over t. Okay, the loop is rotating with angular frequency omega. And so our 1 over t will just be omega over 2 pi. Okay, then you substitute this into here, you get half. The pi cancels out, and then we have omega q r squared in the y direction. Okay, then we are able to find our torque. So we want to find the magnitude. You know the formula is but in the definition, the magnitude will just be the magnitude of mu, magnitude of B, and then sine the angle between the two vectors in this case will just be 90 degrees. Okay, so sine 90 is 1, so you just put half. This is the magnitude of mu. And then with the b, and you are done. So this is the answer, the magnitude of the torque.